Hello, and welcome to Mentor Dino. I'm your host, Caitlin Rossier. I am an architect and founder of Mentor Dino. I firmly believe that architecture, engineering, and construction professionals can achieve true success by embracing human skills as their guiding principle. So each week, I interview amazing professionals in and around the AEC industry as a way to share stories, inspiration, and advice for others finding their own unique career path. Thank you to all of our current subscribers, and if you're new, we'd love to have you join our community. So if you like this episode, please do me a favor and hit subscribe, like, or leave a comment below. It really helps others be able to discover this resource and support them on their own career journey. So let's dive in. I really hope you enjoy this conversation. Welcome to the Mentor Dino podcast. I would like to welcome Ricky McLain, structural engineer and principal at Mass Timber Advisors in Burlington, Vermont. Thank you so much, Ricky, for taking the time to speak with me today.
Yeah, thank you so much, Caitlin, for having me. I'm excited to be here.
So I always start out with my loaded question to introduce yourself and to let everybody know a little bit about your experience and journey so far with the AEC profession.
For sure. Yeah. So I am about 16 years into a career that has traversed several different opportunities and areas of focus. But out of college, I started working for so I specialized in structural engineering in college. And then out of college, started working for a small, about a dozen person firm that did both civil and structural engineering. I was focusing on the structural side. That was here in Vermont, where I am now. And we did a bunch of different projects, didn't specialize in any one thing. There's a lot of ski resorts near us, so a lot of high-end custom family home structural design, as well as, schools, fire stations, police stations, you name it pretty much. There's not very many large or tall buildings in Vermont, so it was mostly in the low to mid-rise size of buildings. And then some unique buildings as well, or unique structures, a few bridges, an interesting shooting range curtain, essentially, to block the lead at a local shooting range. Just a lot of really unique projects that exposed me to a lot, which was good and a lot of fun. So I was there for about 6.5 years or so, and then went to work for a nonprofit organization called Woodworks, who is funded by the softwood lumber industry. And I was there for about 9.5 years, and we provided free design support and assistance to architects, to engineers, to contractors, to developers, but anybody using wood in a commercial or multifamily project, predominantly as the structural material. And that's where I sort of started to get my interest in mass timber, which maybe we can talk about in a little bit. But I was there until very recently when I started my own firm, like you mentioned, Mass Timber Advisors. So at this point, just a short while into that journey and enjoying that.
When you shifted to Woodworks, how did you find them, since they were a little bit, it sounds like, more on the manufacturing side or connected to the manufacturer side?
Yeah, it was interesting. So first of all, they are a nonprofit that provides like design support. So they do work closely with manufacturers, but not actually, manufacturing products themselves, but in some ways representing those manufacturers. So they actually found me through a recruiter, through LinkedIn, which is a platform that, I've become fairly active on. And so, yeah, they reached out, with interest in a position, and over the course of several months, talked some more about it, and it ended up being a great fit. Really enjoyed my time there. I was just going to say, it was really interesting because at the point of time when I was there, at least when I joined, that was 2014. And I kind of mentioned earlier, like my interest, developing an interest in mass timber. What mass timber was very seldomly used, at least in the U.S. at that time. So in a lot of ways, it was just, right time, right place, good opportunity to get involved when mass timber was just starting to grow. And as a structural engineer, it's a super exciting material because, when's the last time we've had this brand new structural building material to learn, to practice with, to understand where it works and where it doesn't, understand the differences in code, watching codes develop real time,
Hmm.
associated with a new structural material. So it's a super, as well for architects, so it's a super exciting time in the industry too, just to be a design professional involved in these types of projects.
Yeah, I know last year I went to, it was like an AIA workshop presentation, part of two parts, and I couldn't make the second one, but it was about mass timber and how it's starting to really take hold in the industry. But some of the codes and different legislation holds it back in some areas of the country where it's really taking off. Out west is more how they explained it to me a year ago, and just showing the values, but how we have to have conversations with our local government and the codes to make sure they understand the material. I'm sure Chicago would not be a huge fan based on the fire for Evergo not wanting to use wood. But how's it been in your area? Because I know it's big out west.
Right. Yeah, and it's really interesting because like just the whole idea of how structural engineers and architects are involved in the building design process, like the building code in the sense of like, what materials can be used, can mass timber be used or not? Like to your point, it's different throughout the country. Coming from a structural engineering background prior to my time at Woodworks, like a lot of those things were conversations that the architect was involved in. And I personally wasn't involved that much in what's the construction type, what are the fire resistance ratings. So I think that's one area that I always advocate for with structural engineers is to learn those things, at least become generally familiar with and aware of those sections of the building code. If we're talking about IBC, we're talking like chapters 5 through 7. And those are chapters, like I said, typically just that the architect deals with. But I think it is important for engineers to get up to speed on those. In terms of like what it's like around here, it definitely varies. I'm in Vermont, like you mentioned, so we're still based on the 2015 IBC, um, whereas I think Connecticut is on the 2021. There's the 2018 IBC is in between both of those, and then the 2024 is the one that's the most current. So, and I think there might even still be a few states in the country that are on the 2012. So it's all over the board. The 2015 IBC was the first time that CLT, which cross laminated timber, one of probably the most common mass timber product, 2015 was the first time that CLT was basically like prescriptively recognized as an allowable building material. Is basically like, everybody knows we can use a structural steel wide flange
Mm-hmm.
shape now, but if you turn to IBC, there's actually a very specific section that references those shapes, manufactured in accordance with a specific standard. So that was only introduced for CLT in 2015. 2018 didn't have many changes for mass timber, and then the 21 and 24 codes significantly changed, specifically allowing much taller buildings. So most jurisdictions in the country do now allow mass timber, but really the difference is, do they allow what we call taller mass timber buildings, like
Mm-hmm.
in excess of 6 stories? So that around here, most jurisdictions don't. I believe the state of Maine does. But on the other hand, like I said, there's not a ton of tall buildings here in New England. Of course, the exception would be like Boston, Hartford, Connecticut, places like that.
Yeah. So what types of projects are you seeing tend to use mass timber? I'm assuming certain project types or um, maybe even just particular owners looking for it. I don't know what you've seen. I've never personally done a mass timber project on my side.
Yeah, it's really interesting because that too has changed over the course of the past 10 years. The codes have changed, like we talked about. These other things have changed, but also the uses, the applications have of mass timber have changed. Um, I would say that right now, a combination of multifamily and institutional, so like university, higher education facilities, um, but more on the multifamily side, it's challenging because of like interest rates right now and cost of construction. It's challenging to make it work, especially on the affordable housing side and the market rate side. it's being done. Projects are doing it, but I think probably not as many as some people might have thought or would like to see. Um, but it tends to, from multifamily anyways, it tends to compete better with, say, steel and concrete, like a post and beam style of building, as opposed to like a 3-story apartment building is typically done out of light wood frame construction. I mean, yes, you can do that with mass timber, but it's not going to compete as well from a cost standpoint. So, multifamily, say at this point, 4 to 12, 14 stories is a fairly common application. And then, like I said, institutional, higher ed, community centers, those types of projects. It used to, when it first was being used in the US, office buildings, I think, were the predominant use case because of obviously what happened with COVID. Just office construction in general has gone significantly down. At the same time, we saw this increased need for more housing in the US. So it was just the confluence there that caused it to really shift significantly from office to multifamily.
Yeah, that makes sense because I think a lot of the projects I've seen have been more office related that have been complete or what I've seen in presentations. So that makes sense that it's kind of shifting since COVID because everything's usually delayed between like when I see things published and winning awards, and those mass timber projects are absolutely
Yeah.
stunning. I'm like, I want to sink my teeth in doing one, but I'm more of a healthcare architect. But that would be a strong suit to try to get on the
Right.
healthcare side. In terms of wellness and well-being, I could see it in very small facilities to try to get that without being the big infrastructure because that connection to nature is just gorgeous.
It is, yeah. I mean, there's a lot of interest in it from a occupant or patient, or if we're talking office worker well-being. There's a lot of studies that have been done. I was actually just looking at one earlier today, where there was a study of 1,000 what they called indoor workers, which primarily were office workers, and basically, looked at what do you like about you. They didn't, try to skew it towards wood or biophilic design, which is kind of this connection with nature, but basically tried to assess what do you like about these spaces and what don't you like about the spaces that you typically work in. And the predominant dissatisfaction was lack of connection with nature. And that could mean lack of direct windows. It could mean lack of plants or wood types of environments, like you see behind me here. Or it could mean lack of accessibility to go outside and take a walk at lunchtime. Those types of things are all ways that we connect with nature. They're super important. There's been a lot of studies that have been done to demonstrate that the more that we have accessibility to those things, things like reductions in stress levels, reductions in heart rate, increased worker productivity, decrease in absenteeism from the workplace environment. So there's some real science behind this idea of biophilic design, and using mass timber as a means, not the only for sure, but as a means to achieve that is a significant reason that, like you said, healthcare, like offices, schools also is another place where that's cited as a common reason for using it.
Yeah, I feel like K through 12 would really benefit from it because some of the older buildings, like I know my high school was very much brick, and there's a lot of interior rooms where I wouldn't see daylight for hours. But
Yeah.
if like heavy timber could be used and connecting everything back to nature, how much more would that help the students in learning and growing their own development? But kind of on that education side, I want to back up a little bit. Um, for anybody looking to study structural engineering, I know I loved my structural classes in architecture school. That if I dropped out of architecture, I was like, I'm going to go be a structural engineer. But for anybody in high school looking to do structures, I know there's kind of the building structure route and the bridge infrastructure route. What what do students need to know when they start out, and when do they have to make decisions?
Yeah, that's a great question because at that age, I think, at least for me, it was very hard to know, first of all, like what are those, if you make decisions now, it really does set you down a path that will probably have a heavy influence on what you end up doing in the future. And I think that there was just a lack of understanding on my part, whether it was due to lack of communication, from others, or just I wasn't paying attention. I don't know. But I think it is important to try to understand at least the kind of the broad buckets of structural design categories. And certainly what you said, buildings and bridges. And I think, within bridges, you might kind of group a bunch of other things into that. Like I would say heavy civil work, and that could mean anything from designing underground utilities, subject to heavy traffic loads. Obviously like the design of abutments, which go along with bridges, to other types of transportation related structures. So, I mean, I think in part it depends on what your interests are, sort of parallel to structural engineering. So, for example, growing up, especially as a teenager, I really loved to do carpentry work, both like woodworking, like building furniture, but then also like carpentry work, like building, I built a shed and helped my neighbor build a garage, those types of things. So to me, I really liked to have both aspects of the planning and the design ahead of time. At that point, I wasn't, didn't know enough to like how to size rafters, but still kind of thinking through, sketching ahead of time. This is what we want it to look like. So the planning aspect, kind of the more common structural engineering aspect of it, and then being able to execute on that design and actually build it. So for me, just because of those pre-existing interests, that's where I gravitated towards, was the building side of things. So I think that's probably also an important part of it. If somebody has a unique interest in trains, for example, or, boats or something like that, and seeing how bridges are designed to allow traffic to go underneath them, those types of things. I think that's certainly not the be all end all, but finding some of those parallel interests and seeing how they might apply to engineering is probably a good place to start too.
Yeah. And then is there like a particular accredited universities that you have to go through? And do you have to make like that structural decision during that point, or is that upon graduation that you pick kind of that path?
Yeah, I'm sure it depends. Well, first of all, there are plenty of, accredited universities. I went to for structural engineering, I went to the University of Maine. I lived there, but it is also a fairly well-known engineering school, but there's lots of really good engineering schools in the US. My experience was that you didn't necessarily, it wasn't like during undergraduate you had to specialize in one or the other, but some of the elective, third and fourth year classes that you take, again, they kind of tend to lead you down that specific road. So the classes that I was taking were things like truss design, structural steel design, concrete design. And yes, those things do exist in both buildings and bridges. So I think, they were leaving enough flexibility for you to choose one or the other. But the other piece I think that comes into it too is one thing that was not required, but heavily recommended, and I did do during undergraduate, was summer internships. And so those are also a really good way to get exposure. First of all, if you don't know what you want to do after college, but to get exposure to things that maybe you just wouldn't have in the classroom or otherwise. So that could mean, exposure working as an intern at an engineering firm, or it could mean other things. Like for me, one summer I worked it was a job site. It was basically like kind of like a strip mall with, several like large box stores and then some smaller stores. But I worked for the plumbing and basically the plumbing contract. We did both like domestic plumbing as well as like the rooftop, oil lines. So really nothing to do with engineering, but in some senses it did have things to do with engineering because it was really good exposure to how structure needs to interact with mechanical and plumbing systems and what that means from a load standpoint, from a penetration standpoint, through fire stopping standpoint, right? So that was a really good experience for me. Another summer I worked for a firm that was basically in charge of getting GIS information for all the wastewater systems in the town that I was living in. So it was a lot of, opening up catch basins, recording the information that's inside there. We had this kind of a satellite backpack to record GPS locations for each. And then at the end of the summer, consolidating all that into a database, plotting all of those locations on the map. So again, not structural building design, but things that all connect with the built environment. And it really helps you get a broader understanding because as structural engineers, as you get more rounded and more experienced, you're not just sizing floor joists, and bolted connections all day long. You need to be able to interface with your clients, with the other, architect, mechanical engineer, electrical engineer, civil engineer, all the people on the job. They're designing those things. So the more that you understand what they're designing, the better you can do your job in a way that also accommodates what they're doing and vice versa.
Yeah, and taking those opportunities for adjacent opportunities. Like I wish, in hindsight, I wish I had an internship with a contractor and seeing how things are actually built and
Yep.
seeing that parallel. But, back then all I thought of was I need to get an internship at an architecture firm. And so it took years to just see other people, some similar experience to me and some having that other adjacent opportunities, and seeing how different their knowledge base is and their different strengths from learning what others do.
Yeah. I think your point about kind of desiring that you had worked for a contractor is a super important point, because that was one of my biggest hurdles, if you will, or learning curves when I started structural engineering, was still having a lack of commercial construction experience, where you can design drawings, or you can draw drawings, draft drawings, or however you do it all day long. But then there's a lack of connection with, is this actually buildable? And is what I'm drawing very difficult to, execute on the job site? So having the experience, like you said, of being out on an active job site for a summer, especially, but even just, getting out on active job sites as often as you can, whether it's organized building tours in your area or something like that. I'm a big proponent of that, because that connection, that feedback loop of, this is what I drew, this is what I designed, this is what it actually looks like in the field, and it's really difficult to implement that, or it went together really well, and here's why. That feedback loop is really important to continuing to improve your design as an engineer or an architect.
Yeah. And we tend to just get the negative, like, this isn't going to get done, go
Yeah,
redesign it. We don't get the positives on, hey, this worked really well, to learn, hey, we need to keep doing it that way. Or, sometimes you just
right.
stumble into a good situation.
Yeah, for sure.
Expanding on engineers figuring out their path, what advice do you have for structural engineers that are looking to get into mass timber, gain that type of experience, or trying to pull that into their projects? I know a lot of the structural engineers that I work with, I'm in an AE firm, so I do have structural engineers. A lot of them are excited about mass timber, and it's just getting that projects to come in the door and that initial experience. Do you have any advice for structural engineers looking for that?
Yeah, definitely. An analogy that I often like to use is, it's, when is the when is the worst time to start saving up for a house down payment? Let's say you're going to buy your first house. When's the worst time to start saving? It's when you already have one under contract, right? Because at that point, it's pretty much too late. You're probably not going to be able to get your mortgage unless you just happen to be sitting on a huge pile of cash. So similarly, in my opinion, when's the worst time to start getting up to speed, or saving money in the bank, if you will, getting up to speed from a knowledge standpoint about mass timber? It's when you have your first mass timber project that comes across your desk, because then, you're supposed to be doing your normal job of designing a structure while also learning this brand new structural building material that you've never worked with before. Not to say that mass timber structural design is incredibly complicated, but it is definitely different. And it's not just the calculations that you're running through, bending and deflection and all that stuff that take different forms. It is that, but it's not just that. It's also understanding how mass timber, number one, behaves differently. Things like it's quite susceptible to vibrations, and other materials may not be. But also understanding how to use it in a most cost efficient manner. Because right now, mass timber is still having a lot of challenges on projects from a cost standpoint. There's a lot of interest in using it. Like you mentioned, some of your engineering colleagues are very interested in using it, but a lot of times those projects don't go forward because mass timber just is too expensive, or it was designed in a manner that maybe didn't use it most efficiently. So not only are you needing to run the calculations, you're also needing to understand the properties of the material such that you can use it very efficiently. So those are some of the areas where it really takes getting sort of a holistic understanding of mass timber. There's definitely some good information out there, in terms of like the actual structural calculation processes to go through. There's been a lot of, good papers written, webinars that are available, videos on YouTube, kind of the whole gamut. It does take somebody being willing to sort of put the pieces together and, understand, this document might be great for vibration versus that video was a great overview of how to check for, structural efficiencies and span lengths versus this connections manufacturer has a really good white paper on how to design connections and hangers, those types of things. But I would say understanding the landscape of the manufacturers, both on the product side, so like CLT, glue lam, DLT, the individual wood products, as well as on the connection side, so fasteners and hardware. I think understanding the landscape of who's out there, because it's not a huge pool at this point, and then take a look at their technical literature, understand how that can then start to be implemented, understanding it, so that ultimately what you're doing with all of this is getting yourself ready for the opportunity that is to come along,
Mm-hmm.
right? And that opportunity might come along just by happenstance, because the architect you're working with is trying to get mass timber used on a project. But that opportunity might also come along because you've gone through the process of learning mass timber, and then you can start to demonstrate that knowledge and expertise, which could be a way to attract work to your company, right? So I think it definitely makes a ton of sense to get up to speed now as opposed to waiting. Because like you said, a lot of people will want to hire an engineer with experience. But if that just means then the same structural engineers continue to do mass timber projects over and over again, it's never going to open the door for new ones to come along. So those new ones really need to get up to speed on the knowledge side.
Yeah, it's always a chicken before an egg thing.
Yeah.
Now, I know you mentioned efficiency with the design. When I think of that, I'm thinking like bay widths, or if there's standard connections that make it more affordable versus, architects creating crazy forms and then saying, all right, let's do it out of mass timber. I'm assuming it's more of a conversation on those efficiency points. Do I have that right? Or can you give me an example?
Sure. Yeah, and that's 90% of it for sure. When you look at the total, like if you were to get a bill at the beginning of a mass timber project from the mass timber supplier, and it kind of breaks down, this is how much the material costs, this is how much the connections cost, this is how much the labor costs to install it, all that stuff. The majority, usually, say 50 to 80% or something like that, of the total cost is the material itself, which is really the reverse of most structural products, which is the majority is the labor to install it. So majority is tied up in the material itself. So minimizing that material to the maximum extent possible is really the biggest way to influence costs. And so to your point about like bay sizes, it really goes hand in hand with understanding, like you talked earlier about the building code, understanding the code requirements for, what is the fire resistance rating. And I usually start there because if you're leaving mass timber exposed and it requires a fire resistance rating, which oftentimes it does, and you can leave it exposed still, but that influences the size of the members, right? Usually if you have sized a floor that's, X thickness and it needs a fire resistance rating, it might need to be a little bit thicker. So starting with the fire resistance rating to understand what does that mean on your member sizes, your beam width and your beam depth and your floor panel thickness, all those things. So that once you know that, like what's the thinnest it can be while still getting you your fire resistance rating, then you come up with your size, let's say your floor thickness. Then once you know that floor thickness, you can say, okay, based on this floor thickness, its maximum span is whatever, 14 feet, 18 feet, whatever that number is. Then can we lay out column bays that match that spacing or increment, or at least are very close to it? Because it's inefficient to say have a panel that can span 18 feet, but you're only asking it to span 13 feet. Or it's also inefficient to say this panel can go up to 17 feet, but I really need my bays at 18 feet, because then you're going to have to go to a thicker panel, and that's going to drive costs up a lot. So yeah, it's understanding those, the influence that fire design has, first of all, on member sizing, and then what the influence member sizing has on span ranges or span ratings for the members to really try to dial in and minimize the volume of wood. And then the second place you go typically after that is the connections, detailing the connections. How do these members come together? How can we simplify that process? Simplify and minimize the fabrication work that the mass timber manufacturer has to do, as well as make it a detail that is fast and easy to install on the job site. There's some, say, a beam to column connection. There's different ways to detail that. One method might take 10 minutes to install on site. Another method might take 25 minutes to install on site. Sure, it's not a huge difference, but if you have, 200 of those connections on the job site, that does add up significantly. So the time aspect, the cost and the time aspect of connections and details also plays into that efficiency piece that we talked about.
Yeah. Just like, I think it's good understanding all of the information you need ahead of time, because a lot of the times the architect will be involved in that early schematic design, sometimes by themselves, and the structural engineer will just be like, hey, this is what we're going to do, and that's how you would do steel and concrete, and that's what it is. But in mass timber, it's got to be a little bit more of a hands-on discussion at the beginning. If the owner wants mass timber or the design wants to go that route, it's all right, we need the structural engineer involved extremely early to see what's possible with that design, to make sure you're not having to, like, I just have nightmares of, okay, now I have to redesign it in CDs because it's way over budget, just because of bay size lengths not adding up. And you don't usually get that information from the contractor of saying, hey, just reduce the bay a foot and you'll save $1 million or whatever amount. Like, they're just like, nope, you're X number way over budget. And so sometimes it can be helpful to have that information ahead of time and making sure we don't design ourselves out of having it in our projects.
Right. No, you're absolutely right. Like, column spacing or bay sizing it's a pretty fundamental aspect of a building's design, right? But it's often overlooked because it's something that's hidden in the end condition, right? It's like lay out the building, and then the structural engineer's job often is where can we locate columns, in walls to avoid being seen, if you will. Versus with mass timber, I mean, first of all, sometimes you want to express the structure, you want to see the structure. So that might be a different thought process. But then also, if you are seeing the structure, not only is it how do you design it, from an efficiency standpoint, like the bay sizing we talked about, but it's also because, especially in something like an office building or an institutional where you might see multiple bays just by standing in one spot, it's that much more important to make it kind of look consistent and clean and repeatable, because you're not, like in a structural steel building, you might have, different column grids just to hide things within walls. Whereas with mass timber, you wouldn't want this kind of irregular pattern of columns and beams and whatnot, not only from a cost standpoint, but just from a visual, aesthetic standpoint. You want it to look clean and consistent. So it's another reason that the column spacing, location of the columns is pretty fundamental on a mass timber building. And like you said, engaging the engineer early to help with those initial decisions is really important.
Yeah. And getting into your own business, Mass Timber Advisors, what services are you providing with that company?
Yeah, I think a lot of it is going to be fluid to try to figure that out along the way, but I can certainly see where a lot of the interest is already and where I would like, a lot of the work to be. And I see that sort of in two different aspects, one of which is a project specific aspect. So, it could be a lot of the things that we've talked about so far, and then those in much more depth where, a developer wants to use mass timber, or at least is interested in using mass timber, but they never have before, or their design team never has before. And they really want somebody to be deeply involved throughout the process and kind of, help hold their hand along the way to help them understand, everything from finding an experienced team to understanding all the nuances of the building code to actually doing the design process with them, engaging other folks that might be able to help throughout the way. So I think that side of it for sure is of interest. And that's something that, I think I'll really enjoy getting back to the project specific side, from my structural consulting days of being involved in a project really from the very start to the very finish. I think then the other aspect of it is more, I guess, what I would call industry or industry related type of work. And what I mean there is, mass timber is a rapidly growing industry. So that means there's new companies getting into the mass timber space all the time, and those could be companies that are making, anything from mass timber products, the wood products, to hardware fastener products, to coatings and sealants, to, fire protecting systems, to erection systems, to software technology, virtual reality platforms. There's a lot that is growing with mass timber and will continue to need to grow along with a growing, market and industry itself. So, um, working with some of those companies to help them understand what is mass timber here and how is it done? How can they enter the market? What types of technical literature are they going to need to come up with to have rapid approvals, permit approvals on projects? Those types of things, understanding how the code allows mass timber to be used. And, so I think there's a lot there that's an opportunity to be involved with helping advance, the use of mass timber for sure.
Yeah, and it sounded like there's a lot of resources out there, but they're scattered. There's doesn't seem to be like a like tried and true like how to or getting everybody up to speed. Everybody's kind of rapidly moving at a quick pace to figure out the system, understand what works, what doesn't work, how to detail it. So I definitely think from the sounds of it that that's a big part.
Yeah, for sure. There's a lot of good resources like through Woodworks, through Think Wood, through FP Innovations is an organization in Canada that has a lot of great resources. And then, like to your point, there have been a lot of other, oftentimes just, consulting companies or architects or other people who have gone through a few projects themselves and have lessons learned, and they're sharing that information. The mass timber is a very, like, I guess I would say, open or collaborative industry where, it could be just lessons learned from this one project, or it could be like there's a specialty consulting firm called RDH, and they've created a couple of really good guides on the moisture aspects of mass timber. How do you protect it from moisture during construction? How do you detail a building envelope that protects it long term? There's some really good resources out there on acoustics design with mass timber. So, yeah, definitely the industry trade organizations have really good information, as well as, just other developers, architects, and engineers who have produced their own literature.
Yeah. What is the recommendation for protecting it during construction?
Well, if you read that document, you'll see that there is a variety of ways to approach it. So I probably can't give you just one, but the variety of approaches, I guess I would say, is maybe at one end of the spectrum, do just about nothing, meaning don't apply additional protecting materials, and kind of just let it be. And then you probably end up with some moisture staining. So you have some
Mm-hmm.
sanding or some washing. I'm not saying that is a good approach, but that is at one end of the spectrum. Sort of a middle approach is, sealing sealants or coatings on the top side of the timber. So as it's exposed to rain, especially, and also UV, it protects it in some regard. A lot of jobs are where two panels come together, or like where there's a box out in a panel for a column to go through, doing some type of tape so that you're not getting moisture infiltration between the panels, because oftentimes that then kind of wicks on the underside of the panel and you get some moisture staining there. And then the far end of the spectrum probably is just a full sheet membrane where you're covering the entire top surface of the mass timber. And sometimes that's done on projects like just at the roof level, and it kind of acts as sort of both temporary roof as well as part of the long-term building envelope. For taller projects, they might be doing that like every second or third floor, to act as a means of buffering the moisture infiltration during construction. Of course, it also depends a lot on where the job is, and what the anticipated weather is going to be during construction.
So it's a little bit more on the staining from water damage. I was thinking, is shrinkage on all, like another issue because of the water penetration in terms of that filtering through as it's getting built?
It can be. It can be. I would say it's not as big a concern as it is on a pure light wood frame project, but it is a concern and it should be thought through. Typically, mass timber products, first of all, are manufactured to lower moisture contents. Like you might buy a 2x stud from your local lumberyard, you probably see a stamp on it that might say KD19. That means kiln dried 19. 19 is moisture content. So versus like mass timber is manufactured, depending on the product, anywhere from say 6 to 14% moisture content. So it's manufactured at a much lower moisture content to start with. The reason that that's important is because ultimately it's after you close in the building, it's going to settle down to what's called an equilibrium moisture content. And for most interior conditioned spaces, that's going to be somewhere around 9 to 12%. So the closer you are to that 9 to 12% when the products get to the job site and are installed, the less shrinkage that's going to occur. Because if there's no increase or decrease in moisture content, there's no shrinkage or expansion. Versus if it settles down to 10%, but it started at 25, like that's when you get a significant amount of shrinkage. So the fact that it's manufactured the lower moisture contents to begin with is helpful. And then also, just the fact that you're typically, depending on the product, but you're typically having some type of cross orientation with CLT anyways, where that helps provide some dimensional stability. Whereas, if the lumber is all running one direction, it's going to shrink all uniformly. Versus like CLT, you have these interlocking layers. So one surface might try to shrink, but the other surface kind of restrains that because it would go, it would basically restrain it because of the different orientation of the grain. So it is a more dimensionally stable product. CLT is, anyway. So it can shrink, it can expand too, and it should be something that's thought through in the design, but it's usually not as significant amounts of movement as like a pure lightwood frame building.
Gotcha. That makes sense. And I know you've recently transitioned to being an entrepreneur. How does that feel transitioning from an employee to an entrepreneur? Because you're in the heart of it.
Yeah. Yeah. It's, I think I've described it to some people as like all of the emotions, like excitement, fear, pretty much all of it. But, it's a lot of fun too. It's very different. First of all, in terms of being an employee versus an entrepreneur, you have a lot of freedom. You also have a lot of, weight sort of that hangs on your shoulders, if you will. I've always been interested in being an entrepreneur. That's the type of environment that I grew up in. Both of my parents were entrepreneurs. My wife and I had a small brewery a little over a decade ago, and that was a lot of fun too. So I always felt like someday I would get there again. And so yeah, it's been a lot of fun. It's been a unique experience so far in the very short amount of time that it's been. It also is just like you never necessarily know what to expect. You get an email. I got an email last night that I wasn't expecting to get, but it generated some work that I was able to jump on. And then some days go by and you don't get those. So it's really just, you have to be flexible. You really have to plan ahead for those days when something doesn't come in. You've got several other things lined up. But at this point, being a one person shop, also making sure you're not over extending yourself and lining up too much, so, definitely a learning process, and I'm sure will continue to be for pretty much forever. But I'm enjoying it.
Yeah. I'll have to check back in and see how it's going. Are you going to start brewing beer again now that you have time? Maybe.
I don't know. I don't know. I've thought about it, but at this point, there's a lot of really good breweries in Vermont too. So, might just stick with that.
Yeah, I used to brew my own beer, and I started to just cool off on brewing beer and just enjoying everybody else's beer that's going on around me in Pittsburgh. So
Yeah.
I know the process.
Oh yeah. Yeah. Right.
Have there been any organizations that have really impacted your career or that you're currently a part of that you're excited to talk about?
Yeah, I mean, a few for sure. Like I think back to, I've had a couple of pretty key mentors that I would say, in my life. One of them was the first at my first engineering job. My direct boss there, um, he taught me a lot of just the basics of structural engineering, but also I think one of the things that he really instilled in me was the importance of communicating with clients, but then also, like the other professionals that you're working with. So I remember very distinctly one of the things he told me is that you need to be able to explain something three different ways to three different groups of people or three different audiences. And that, first of all, that really teaches you how to master a subject, as well as how to communicate appropriately with other people, right? Like if it's a challenge you've come across on a job and you're trying to explain that challenge to the developer or the owner, they probably don't care about the technical details that you might need to get into with the mechanical engineer, and you can, multiply that across all the people involved in the project. So that to me was really important in understanding effective communication styles. When I started working at Woodworks, I had another mentor. Her name is Lisa, and she was really helpful in getting me up to speed on, like I mentioned earlier, the aspects of design that I wasn't involved in from a structural standpoint, like fire and life safety, like acoustics, like all of the other things that go into a building design that purely in structural engineering just didn't have exposure to. And I think they are very important when it comes to mass timber. So that, I've always tried to be quite local in like local or be quite involved in local SEA groups, structural engineering associations. There's a couple of groups here in New England that are geared towards like passive house and high performance design. I've really been interested in that for a long time, and try to go on as many like building tours as possible. There's a local group called the Vermont Green Building Network, I believe it's called. And so like they host tours and dinners and whatnot that I try to participate in because again, I love getting out on active job sites. So it's good for that. And I love meeting other professionals kind of a similar interest. And they don't have to love mass timber. Maybe I do, but they love designing and building very high quality buildings. So there's a ton of mutual interest there, and just meeting those people, for connections and hearing about what other people are working on is really good.
Yeah. And just fun getting on site on projects you're not working on because you can always learn something from somebody.
Yeah, exactly, for sure.
And I always like wrapping up my podcast with this final question. And it's, what advice do you have for young professionals just starting their career?
Yeah, great question. I mean, first of all, if you are just starting your career in some type of building or structural design, um, good for you. I think there's so much opportunity in the building design or just any type of structural design industry where your career path certainly can be, in office design. It doesn't have to be if your interests lie elsewhere. There's so much opportunity. You could be a rep working for a manufacturer of some sort. You could be working for a trade organization like I did for a number of years. Ultimately, you could be starting your own company, or, you could be working for a contractor who has in-house design services. So I would say, use your first years or your early years to really figure out, first of all, where your strengths and weaknesses are, how you can work on those, and then where your interests lie. Like I mentioned, for me, a lot of my interests early on were in the confluence of the design and the construction. And I was doing that all with wood because that's really the only material a single person at their house can build a shed out of. So that ultimately, whether consciously or not, I think led me down this road of kind of mastering the subject of wood design, but then also being able to teach that to other people. So really try to just understand where your interests are, and know that there's a ton of ways that you can approach your career. Take all the experience you can get now, and if that means a variety of experiences, I think that's great too. But know that your career can continue to evolve, and I think that's a really good thing.
Yeah, that's amazing advice. And you also never know where you're going to go. I'm sure you didn't plan on
Exactly.
specializing in mass timber when you first started your career. So,
No, not at all.
And if anybody wants to get a hold of you, has questions about mass timber, or could use your services to help out, what's the best way to get a hold of you?
Yeah, thanks for asking. Our website is probably the best way to get a hold of me. The website's masstimberadvisors.com. And there's a contact form through there. You can kind of just get a feel for the types of services we provide. And then we just have an email address that's more of a generic one, but I see all those emails too, which is just hello@masstimberadvisors.com. And I'm also fairly active on LinkedIn if anybody wants to connect there too.
Yeah, I'll leave your website and your LinkedIn in the show notes so they can make it very easy to find you and ask questions.
Awesome. Thank you.
Thank you so much, Ricky, for taking the time to speak with me today. I know mass timber is always beautiful in my eyes, so I was very excited to learn more about structural engineering, but also the mass timber side. So,
yeah, thank you so much for having me. This was a lot of fun. I appreciate it.
I hope you enjoyed our discussion today. Learn some advice to take with you and see how our industry is all tied together to create the world around us. Check out the description below for any links or resources we discussed. If you liked the episode, please do me a favor and hit the subscribe button. Give me a thumbs up and leave a comment below. It really helps others be able to discover this resource and support finding that career path that best works for them. If you know someone that has inspired your own career that you'd like me to interview, let me know in the comments below, or you can reach out to me via my website or LinkedIn. I'd be happy to share their story or your own. Thank you again, and I cannot wait for the next career story I get to share with you next week.